Hello students, myself Lakshajyoti Majumdar. So chemistry here. So I am here in Genesis Coaching Institute, BAZAR, Guwahati. So today we'll start a very interesting topic which is known as mole concept. So without mole, chemistry is nothing. So let's start. So mole. What is the definition of mole? Mole is nothing but an amount of substance. Now, what is amount of substance? It is in terms of mass, it may be in terms of number, or maybe in terms of volume, whatever it is. But all constitute 1 mole. Now, here mole, there are basically 3 definitions of mole. The first definition, it is in terms of mass. Say, this is the first definition of mole in terms of mass. So if we will take 1 mole of carbon atom. Now carbon atom, you know the atomic mass of carbon. So it is 12 gram. So this is 1 mole. If we will take 1 mole of oxygen molecule. See here. Firstly, we are dealing with the atom, atomic mass. It is the molecule now. So now it is molecular mass, which is 2 into atomic mass of oxygen, which is 32 gram. So this is the first definition of mass. First definition of mole in terms of mass. Coming into the second definition, which is in terms of number. Number is nothing but the Avogadro's number, which is 6.02 into 10 to the power 23. So if we will take 1 mole of carbon atom, see how many carbon atoms are present. Here only 1 carbon, that is why here 6.02 into 10 to the power 23. Now what is the unit of this? It is number of carbon atoms. Okay, so it is, we are dealing with here atom, that is why here number of carbon atoms. If this is number of oxygen molecules, say 1 mole of O2 molecule. So see here how many O2 is present. O2 is only 1, that is why here it is 6.02 into 10 to the power 23. Number of O2 molecules. Number of O2 molecules. So when you convert this molecule into atom, see how many atoms are present now. Here 2 oxygen atoms are present. That is why 2 into 6.02 into 10 to the power 23. The unit is number of oxygen atoms. So go through the question very carefully, because molecule, it is converted in terms of number of molecules as well as converted into number of atoms also. Third definition, this is the second definition of mole concept. Third definition is in terms of volume, which is 22.4 liter at STP, standard temperature and pressure. So this value is fixed, whatever the condition is. Here 1 mole of oxygen molecule equal to 22.4 liter at STP. This value is fixed. Now we have 3 definitions of mole in terms of mass, in terms of number, as well as in terms of volume. So if we generalize these formulas, we have this equation. Here N, it is the number of moles, equal given mass divided by atomic or molecular mass. If we are dealing with atom, then atomic mass. Dealing with molecule, then molecular mass. Second, given volume divided by 22.4 liter. 22.4 liter at STP. This value is fixed. Now, Third one is number of atoms, or you can say that number of particles. So it depends on number of particles, for example, electrons, protons, neutrons. So it depends on the question that what is the value of P. If it is in terms of molecules, then P is 1. In terms of electrons, it depends on the system. So here the number of particles divided by P into 6.02 into 10 to the power 23. Here P stands for number of particles. So this is about the mole. Now, sorry, with the help of this, okay, clear? So with the help of this, we are going to evaluate the stoichiometric equation. Now, what is the meaning of the stoichiometry? Stoichiometry is nothing but the ratio of the atoms in a particular molecule is fixed. Means, say for example, carbon dioxide, CO2. Now, the ratio between carbon and oxygen in CO2 is always fixed, which is 1:2. In case of water, the ratio of hydrogen and oxygen in H2O is 2:1. So this is known as the stoichiometry. Now this stoichiometry, if we are applying in equation, so this is the stoichiometric equation. So let us take an example. Say methane reacts with oxygen to give carbon dioxide and water. Any hydrocarbons, it may be alkane, may be alkene, may be alkyne, or the aromatic one. Sorry, on combustion, it will give carbon dioxide and water always. Now balance the equation. Here it is 2, it is 2. Now balanced. Now go through one by one. How many moles are present here? Since 1, that is why it is 1 mole of methane reacts with 2 mole of oxygen to give 1 mole of carbon dioxide and 2 mole of water. So if we write in terms of number, here it is molecule, so molecular mass. So what is the molecular mass of methane? 12 plus 4, 16 gram of methane. Here it is oxygen, O2, 16 into 2, already 32, into 2. So 64 gram of oxygen to give carbon dioxide. Find the molecular mass. 12 plus 32, it is 44 gram of carbon dioxide, and H2O, this one is 2 plus 16, 18, 18 into 2, it is 36 gram of water. So it is in terms of mass. Now go in terms of number. Number, here I can write the Na. Na, it is the Avogadro's number, which is fixed. Now 1 mole is there, it is in terms of molecules. So Na, number of CH4 molecules, reacts with 2 into Na, number of O2 molecules, to give Na, number of carbon dioxide molecules, and 2 into Na, number of H2O molecules. And the last is in terms of volume. So here it is 1 mole, I already know that 1 mole is 22.4 liter. Here 2 mole means 2 into 22.4 liter. 1 mole 22.4 liter, and 2 mole 2 into 22.4 liter. So it is about the stoichiometric equation. Now just shuffling these things. If I say 1 mole of methane, no doubt we know that it reacts with 2 mole of oxygen. But if I say 1 mole of methane reacts with 64 gram of oxygen, it is correct? To give Na, number of carbon dioxide molecule, these values are, see these values and these values. Na, number of carbon dioxide molecule, and 2 into 22.4 liter, H2O. So all values are in equivalent. So we can take anything. Okay? So this is the stoichiometric equation. 1 mole of CH4 reacts with 64 gram of O2 to give Na, means 6.02 into 10 to the power 23 number of carbon dioxide molecules, and 44.8 liter of H2O. Same equation. So now we are going to do one numerical. Say, on combustion of 8 gram of methane, 8 gram of methane produces how many gram of H2O? This is the question. Remember this question. Okay. So the equation is methane is given. On combustion means reacts with oxygen. It will give carbon dioxide and water. Balance it. You know the equations, because on combustion it will give always carbon dioxide and H2O. Now originally the molecular mass here it is 16 and here this one is 36. Now first going through the equation. Say 16 gram of CH4 produces 2 into 18 gram of H2O. Is it correct? 1 mole 16 gram, 2 mole 2 into 18 gram. Now in question it is given 8 gram of methane. So therefore 8 gram of methane produces how many? So 2 into 18 into 8 divided by 16. The total is 18 gram of H2O. Means 8 gram of methane produces 18 gram of H2O. We know this one because we know the equations. But if this type of question is coming that you don't know the equations about the inorganic chemistry, remember this value. It is 18 gram. Okay. The answer is 18 gram of H2O. Take another question. S8, or you can say that 2.56 gram of S8 undergoes various chemical reactions and transformations. 2.56 gram of S8 undergoes various chemical reactions and transformations and ultimately produces MgSO4, magnesium sulfate. Now, what is the mass of MgSO4 produced? What is the mass of MgSO4 produced? In this type of question, we don't know the equations because acid is given. Ultimately, the product is magnesium sulfate. So, from where the Mg coming from where oxygen, we don't know. So, in this type of equation, we are applying one principle which is known as POAC method. POAC means principle of atom conservation. Just like, say, the energy law of conservation of mass, law of conservation of energy, same type law of conservation of atoms. Okay, atoms can neither be created nor destroyed. For example, in case of carbon dioxide, in the reactant part, carbon and oxygen give CO2. Okay, so in the reactant side, 1 carbon, 2 oxygen atoms. In the product side, 1 carbon and 2 oxygen atoms also. So neither created nor destroyed. So POAC method, this method. So here 2 conditions are important for this type of questions. First, reactant and products must be given. This is the first condition. Reactants and products must be given in the equation or in the question, and there must be 1 common atom. I repeat, there must be one common atom and reactant and product must be given. So here, say this is the reactant part and this one is the product part. It is number of common atom into given mass divided by molecular mass. This is about the reactant. Then number of common atom into given mass divided by molecular mass. This is about the products. Now see in S8, this is the reactant. How many, what is the common atom between S8 and MgSO4? Obviously it is S. So see how many S is given? 8. So 8 into given mass is given 2.56. 2.56 divided by the molecular mass of S8, which is 256, means 32 into 8, equal in MgSO4, 1 sulfur is there, so 1 into given mass, you have to calculate the given mass and the molecular mass. This is 24, 32, 64. The total is 120. Now after calculation, you are getting here the given mass, which is 9.6 gram. This is the answer of this question. So here we can get that answer with the help of POAC method. Now remember these things. This is the first question. Answer is 18 gram. Now see, here methane is given. It is the reactant part. H2O is given, product part. Both are given and there must be one common atom, so hydrogen is the common factor. Now apply this into this equation. So here 4 hydrogens are present, 4 into given mass is 8, methane molecular mass is 16, equal 2 hydrogen atoms, 2 into given mass, you have to evaluate, molecular mass is 18. Now calculate. See, the given mass is 18 gram. It directly dictates with this equation. Means if we know the equation or if we don't know the equation, if we you are applying the POAC method, unless and until 2 important factors, 2 important parameters should be there. There must be one reactant part and one product part, and there must be one common atom. Okay? So it is all about the stoichiometric equation. Thank you.